Hi guys, welcome to Night Science Stories. Breathe in slowly and let your shoulders drop. Tonight we will drift together into the quietest darkness on our world. We will visit the deep ocean, a place so gentle and so immense that time itself seems to exhale there. Imagine the surface at dusk. Waves turn from silver to a deeper blue, and the last warm color slides from the sky. We leave behind the sound of wind and the clink of rigging and begin to descend. The water at first is familiar. Sunlight still threads down in bright shafts, and you can see your hand and the gentle swirl of bubbles that follow you like tiny moons. Then the brightness thins. Reds vanish first, then the oranges, then the yellows. All that remains is the cool blue that hangs on the longest, and even that becomes a dim whisper. We enter what oceanographers call the twilight zone, a band of water so calm that a whisper would carry if sound could travel that way. No sun reaches this band directly. Instead, you are surrounded by a dreamlike glow from above, as if a ceiling of frosted glass were filtering daylight into 1,000 soft memories. Here, fish begin to change. Their bellies shine faintly with light of their own. Their backs are dark as ink. They do this to erase themselves, to match the faint sky above and the deeper night below. Keep drifting. The twilight yields to true night. The sea turns velvet and the surface world disappears. Mapping this dark vertical world is not simple. We think of the ocean as a blue plate on a map, but it is really a living mountain range of water. If we could drain the seas for one slow hour, what would remain would be a world of cliffs, valleys, and plains large enough to cradle continents. The first step offshore is a broad shelf, a kind of terrace that once held forests and fields when sea levels were lower. Past the shelf, the ground drops along the continental slope, a quiet escarpment that falls into the great plains of the abyss. These plains, smoother than deserts, cover a great share of the planet and carry a rain of fine particles that fall for months before they finally rest. Across the plains rise long chains of mountains, the mid-ocean ridges, where the crust of the earth opens and new rock is born. In other places, the crust bends and one plate slides gently beneath another. There trenches appear, narrow and deep like ink strokes on the sea floor. Valleys that reach farther down than the highest mountains rise into the sky. When we say deep ocean, we mean not only a horizontal expanse, but a set of vertical neighborhoods, each with its own light, pressure, and rhythm of life. Pressure increases as we sink, not in a hurry, but with unshakable patience. Near the surface, the weight is the weight of the air that lies above the sea. With each additional 10 meters of water, the world adds the equivalent of another layer of air. Imagine a quiet hand placing a book upon your palm every few steps downward, never stopping. Soon there is a library pressing upon you. The deeper you go, the more absolute the hush becomes. Soft materials compress. Air vanishes from spaces that once held it. The hulls of deep diving machines must be shaped like spheres or thick cylinders, because any corners would crumble. For creatures that live here, this pressure is not an enemy. It is simply the weather of their world. Their tissues hold little to no compressible gas. Their bones, if they have bones at all, are thin and flexible. The marine snailfish that glides along trench walls is delicate and translucent, a ghostly traveler adapted to pressures that would turn a human submarine into glittering confetti. Glycine and other small molecules in its cells help its proteins remain stable, so life's chemistry can continue even while gravity's hand tightens. Pressure here is not a shout, it is a very slow embrace. Cold follows pressure as a companion. In the deep ocean, far from volcanic warm spots, the water rests just above the freezing point of salt water. Not ice cold, but the kind of cold that creeps into stone. This steady chill is not hostile. It is simply constant, like a metronome that keeps time for the planet's longest symphony. Life answers with its own patience. Many deep-sea animals move slowly, not from laziness, but from precision. Their hearts beat with deliberate rhythm. Their stomachs digest food over long spans of time. A faint warmth is made within them. Not much, only what is needed, as if their bodies were winter houses with heavy blankets and small fires that never go out. There are exceptions. Around hydrothermal vents, places where seawater meets hot rock and returns rich with minerals, the cold is broken by breaths of heat. There the water can be warm enough to fog your imaginary lens, or even hot enough to boil if not for the weight that holds it liquid. But the general rule is gentle and clear. In the place where the world stores its midnight, temperature rarely surprises you. Out of this long night rises a strange lantern festival. Many deep-sea creatures make their own light. The science is peaceful and elegant. Inside their cells or within small organs called light-bearers lie chemicals that meet and glow. One is often called the light bringer. Another is a helpful protein that guides the reaction. When they meet in the presence of oxygen and sometimes in the presence of a small helper that behaves like a calm assistant, there is a tiny release of energy as light. The color is almost always blue-green, a shade that slips most easily through water. This glow is not just decoration, it is language. A comb jelly ripples with moving windows of light to startle a pursuer. A small fish hides its silhouette by shining with the exact brightness of the faint glow above, a moving counterfeit of empty water. A dragonfish carries a light on the end of a thin filament, and the light is food's favorite color. In the deep Red Sea, some fish even carry filters that let them see and produce a dull red light, invisible to their neighbors, a private beam in a public night. Many patterns are carefully timed. Some are bursts like sighs. Others are steady like a clock. If you watched in slow motion from a quiet perch, the dark would sparkle like a city seen from an airplane at night. Eyes in this darkness are miracles of design. Some animals choose to have very large eyes to gather any light that exists. The colossal squid has eyes as wide as a dinner plate, which can catch the pale shiver of a distant giant shadow. Other creatures go the opposite way. They make themselves transparent so that light passes through them and no shadow gives them away. The barrel eye fish has a clear shield over its head and two tubular eyes that point upward like twin telescopes focused on the dim world above. When food drifts by, the eyes can rotate forward to watch the mouth as it takes the meal. Shrimp and crabs carry mirrors made of crystals that focus light without lenses. Some squid are born with a skin that carries tiny tiles which can switch between colors or even reflect polarized light, the same kind of light that dances from the surface of a lake when you tilt your head. In this place, vision does not only mean seeing with eyes. Some animals sense faint vibrations with long hairs. Others use electric fields. Many depend on smell that moves with currents in long feathered antennae. The night is full of senses we barely understand. The bodies that live here are tuned to a slow exchange of energy. Food is scarce, so waste is rare. The giant isopod, a relative of the pillbug that lives under garden stones, can feast once and then wait for months without another bite. A Greenland shark from colder northern waters can live for longer than any other known vertebrate, perhaps for centuries, moving like a slow cloud. Deep sea corals build red and black skeletons ring by ring, and some have been dated to more than 4,000 years, a patience written in mineral calligraphy. Many animals here are small but elegant. Others become large, not from speed but from thrift. Gigantism in the deep sea is a kind of quiet success where a body grows big because there is no daily race and no sudden winter. Muscles are light and watery. Bones, if present, are thin. To us, this looks fragile. To them, this is wisdom. They carry only what they must. Food falls from above in a slow snowfall of tiny things. Marine snow is a poetic name that is also accurate. The particles are bits of plankton shells, fragments of plants and animals, a smudge of mucus here and there, and the products of digestion shaped into tiny pellets by creatures that graze in the lighted waters of the day. This snow drifts for weeks and months. On the way down, mid-water animals catch it. Bacteria soften it. Fatty bits grow fragrant and attractive to sniffing palates. On the bottom, the snow collects in hollows and along ripples where small worms and sea cucumbers sift it with mouths that never hurry. Sometimes a much larger meal arrives. A dead whale sinks, a continent of fat and bone that becomes an island of abundance. Hagfish braid into knots to pull at the flesh. Eels lift their heads like dark flags. White bacterial mats appear as if a fog had turned solid. Later, there is a stage where the bones themselves become homes, and yet later the island fades and the desert returns. Although the deep seems still, water is always moving. There are currents we can name and others that are subtle. Cold, salty water forms near the poles and slides along the seafloor like a river of ice that never freezes. Warm surface water moves in broad gyres, driven by winds and the spin of the earth. Between these broad movements are narrow ones. Down-welling carries water from the surface toward depth, sometimes right beside an underwater ridge. Upwelling returns nutrient-rich water toward the light, and with it blooms of life appear at the surface like fields after rain. Within the deep, animals ride these rivers. Many undertake a daily migration. As night falls at the surface, small fish and plankton rise hundreds of meters to feed under the cover of darkness. With dawn, they return to the twilight and beyond. This is the largest animal commute on the planet, and it has gone on for ages. Imagine a vast elevator of life, rising and falling every 24 hours, powered by sunlight it never sees. We have spoken of plains and ridges. Now picture cuts in the seafloor where the world folded upon itself. The great trenches are quiet corridors where gravity does its secret work. The Mariana, the Tonga, and the Kuriil trenches are well known, but beyond them lie many unnamed valleys. Pressure there reaches its greatest steadiness. The deepest points are very close to 11,000 meters, a figure that is simple to say and almost impossible to imagine. At such depths the water is heavy beyond intuition, yet life is present. A pale snailfish has been filmed deeper than 8,000 meters, fluttering with delicate fins like silk. Amphipods, which are small crustaceans, scuttle with cheerful speed despite the pressure. Bacteria and tiny archaea are everywhere, clinging to rocks and living in the pores of mud. These trenches are not isolated. They connect to the ocean's circulation and to the geology of the planet. Minerals that settle there may eventually be drawn into the mantle of the Earth and return as volcanic gases many thousands of years later. The trenches are part of a slow breath that joins water, rock, and air. Let us rest for a moment near a hydrothermal vent, a place where this slow breath becomes visible. Imagine a field of chimneys made not of brick, but of minerals that precipitate out of hot fluid as it meets cold seawater. From their tops pours dark water, rich with metals and sulfur. The darkness is not dirt. It is a cloud of tiny particles that form when the hot solution meets the cold ocean. Around the chimneys are gardens of strange forms. Tube worms rear like organ pipes with bright red tips that are actually the blood-rich plumes through which they breathe. Mussels and clams cluster in heaps the size of cars. White crabs scuttle with lifted claws as if measuring the heat. These creatures are fed not by sunlight but by chemosynthesis, a process in which bacteria use chemical energy to fix carbon, building sugars from carbon dioxide and water using the energy stored in reducing agents such as hydrogen sulfide or methane. In simpler words, bacteria make food from stone breath, and larger animals host the bacteria in their tissues like friendly farms. When a vent shuts down, the garden fades. When a new vent opens nearby, a new city blooms. The entire neighborhood can shift in a few years, which in this part of the ocean is the blink of an eye. There are other oases where methane seeps from the seafloor. Mats of bacteria gleam like fallen clouds. Sometimes the seeps form pools of brine, saltier than the sea around them, with edges that look like shores. A fish that swims into a brine pool does not return. It sinks as if through a window into heavy syrup. Yet on the rims of these pools live communities of worms and clams that thrive on the chemistry of methane and sulfate. Even on the wide plains of the abyss, starfish and soft medusae drift near the bottom like lanterns. There is very little waste here. Skeletons and shells are recycled into new forms. The seafloor we once called empty is as intricate as a night sky that at first seems black and then resolves into 1,000 points. Sound travels far in water, farther than light and farther than smell. In the deep ocean, you can hear glaciers groan and crumble as they carve into the sea. You can hear the drumming of storms from thousands of kilometers away, a deep rolling that arrives long after the clouds have passed. The great whales sing along lines in the water where temperature and depth permit their voices to carry with minimal loss. Sperm whales click with a sound like polished wood struck by a stick, bright and percussive, a language of measure and perhaps of dreams. Shrimps snap in huge choruses in shallower waters, and their crackling blankets the background like rain upon leaves. If you could translate this soundscape into a picture, it would be a long landscape of hills and valleys, with rivers of quiet and mountains of noise. The deep is not silent, it is attentive. To explore this world, we send machines with careful hearts, bathyscaphs, remotely operated vehicles, and free-falling landers all make the journey down and up again. The safest shapes are spheres and domes, because pressure loves to find corners. Cables unwind with patient grace. Cameras adjust to darkness with slow eyes. Scientists paint their instruments white so that they can be found again on the seafloor, and sometimes they add a small timer that releases weights at an agreed-upon hour, so the instrument floats back to the surface like a seed. Even with this technology, most of the ocean remains unseen. The cost of time and distance is high, but the work continues because each visit reveals a new note in the long song of the deep. A few brave humans have gone down as well, wrapped in thick hulls with windows like crystal pearls. They speak of a darkness that feels pure and friendly, a darkness that asks you to listen rather than to look. From far above, the deep ocean seems disconnected from our lives, but it is not. The slow movement of cold water along the seafloor helps steer the climate of the surface. The deep is a warehouse for carbon, a place where the remains of plants and animals are hidden away from the air for long periods. When the small creatures of the surface make their daily commute up and down, they move nutrients and carbon between layers, tying the ocean together like threads in a woven cloth. Even the largest storms are softened by the ocean's ability to absorb heat. In that way, the deep is a kind of buffer for the planet, a cushion that turns sharp shocks into long, slow waves. The deep also keeps memories. Sediments on the seafloor hold thin layers like pages of a book. A layer rich in ash tells of a far-away eruption. A layer heavy in tiny shells tells of years when the surface bloomed. The shells themselves, made of calcium carbonate, carry hints of the water in which they formed, including its temperature and its chemistry. Scientists take slender cores from the seafloor and read them slowly, page by page, a history written without words. Ice cores do something similar in the polar regions. Together, they show that the planet breathes on long timescales, that currents rearrange themselves like furniture in a quiet house, and that life adapts with patience. Humans leave marks here as well, even without touching the bottom. Tiny fragments of plastic drift downward in slow confusion. They settle into the mud and become part of the modern layer. Lost fishing gear finds its way down and tangles against outcrops. The good news is that the deep is resilient when given time. Where waste is removed, animals return. Where traffic slows, larvae find places to land. The single best gift we offer the deep is rest. It helps to remember that the ocean did not begin as an alien realm. It was the first home of life. Long before the first forests breathed the air, microbes learned to gather energy in the sea. Over time, they invented pigments that could take in sunlight and turn it into sugar. That sugar fed larger bodies that crept, swam, and finally walked. The deep in this story is an elder relative who never left the old home. Visiting it is a kind of return. The patience that rules there is the same patience that once ruled the entire planet. Return now to the image of your descent. You are in the quiet water beyond the reach of the sun. You can see the faint sparks of animals signaling to one another, small greetings written in blue. You can feel the softness of the current as it slides past you like silk. You know that somewhere far above a storm is scratching at the surface, but here the storm is only a distant rumor. Below you are valleys as deep as thought. In those valleys are gardens that never see day, gardens fed by rock and chemical breath. Along the plains run travelers whose bodies are made of light and jelly and patience. The deep is no longer a blank. It is a city with 1,000,000 windows, and every window opens on a small and necessary life. We have visited only a fraction of what can be said, and already the calm has grown thicker than water. Perhaps you are thinking of bioluminescent signatures as whispers exchanged behind cupped hands. Perhaps you are picturing a vent field like a city in winter, with white plumes rising like smoke and crabs crossing the streets. Perhaps you are hearing a whale song stretched across the ocean like a ribbon. All of these are true in their own way. The deep ocean is a library with many rooms, a cathedral with many chapels, and a night sky with too many stars to count. Let us rise a little, just enough to see the twilight again. The blue glow returns, as if a page were being read from beneath. A few jelly forms drift upward with us, and small fish fold their lights away as they approach the paler layer. The water warms by a degree or two, pressure eases, the world brightens by shades and steps. In the distance, the surface is a mirror with a sky written upon it. We break through very gently. A breeze combs the waves. The taste of salt is soft, and the coasts of the continents are asleep, not knowing that beneath them stretches a country vast and peaceful, full of slow dances and whispered light. If you rest now, the ocean will keep watch. Its night is endless, but not empty. It holds the deepest quiet on earth, not because it lacks life, but because life there has learned a slower music. And that music, when you listen, sounds a lot like breathing. The water around us grows still and heavy as a theatre about to lift its curtain. Ahead, along a dark ridge where the crust of the earth opens to the seafloor suddenly breathes. What appears first is a ghostly shimmer, as if the water itself had become glass warmed by an unseen fire. Then the chimneys appear. They are not made by hands. They rise by quiet chemistry. Superheated water, rich in minerals, surges up through cracks in the rock and meets the cold, deep ocean. The shock is immediate. Metals and sulfur fall out together as tiny grains and build fragile stacks. From their mouths pour black plumes that look like smoke from chimneys on a winter morning. Because of this color, explorers named them black smokers. The plumes are not soot. They are clouds of mineral dust so fine that they hang in the water for a long time before settling like the gentlest ash. Around these chimneys, life gathers as if answering a bell. Large red-tipped tube worms stand in groves like organ pipes. The bright tips are not flowers. They are blood-rich plumes used for breathing. The worms have no mouths and no stomachs. Inside their bodies lives a populace of bacteria that feed them. The bacteria take the energy of chemical reactions and use it to build sugars from carbon dioxide, just as green plants use sunlight. The host feeds the guests with sulfur-rich fluids drawn from the vent water. The guests pay the rent with food. There are mussels, clams, blind crabs, and white shrimp that swarm and then retreat in a sparkling cloud. Fish with pale skin ghost by. The water itself is hot enough to sting, but only a few finger widths away it is cold again. This knife edge between cold and heat marks the border of an entire city made from stone breath. When these vents were first seen by cameras in the late 1970s near the Galapagos region, scientists had expected bare rock and a faint drizzle of dead plankton. Instead, they found more biomass than in many sunlit areas above. It was as if night had produced its own day. The lesson of the vents is simple and deep. Life is not married to sunlight, it is married to energy and to the means of building the molecules of self. Where the planet lets minerals meet water and exchange electrons, oxygen poor though the place may be, life sets the table. Even the black plumes themselves are useful. As the fine particles drift and settle, They form layers of metal-rich sediments that, in the slow future, may become ores within mountains long after the ocean floor has slid beneath a continent. A vent field is a moment in a very long story. Not all oases glow with heat. On many continental slopes, methane seeps rise in gentle streams. The gas comes from buried pockets within the sediment or from chemical changes deeper in the crust. When this methane meets cold seawater under pressure, it sometimes forms crystals that look like frost. They are called hydrates, and they trap gas within a cage of water molecules. On deck, a block of hydrate looks like ice that can burn with a blue flame. Down in the deep, hydrates resemble snowdrifts along the base of ridges. Around the seeps, bacteria harvest the energy of methane and of the reaction between methane and sulfate in the water. They knit together mats as pale as skimmed milk. Clams and mussels live on top, farmed by the microbes inside their gills. Long-lived tube worms anchor to carbonate crusts that form where seep fluids alter the chemistry of the sediment. Some of these worms can live for centuries, growing only the width of a fingernail each year. Cities of worms is not a metaphor. They are cities built from patience. Walk your eyes from these oases to the open water. It is filled with builders that work in glass. Radiolarians and diatoms fashion their skeletons from silica pulled from seawater. The designs are elegant beyond jewelry. Radiolarians arrange spines and cages in lattices that look grown from snowflakes and cathedral windows. Each form is an answer to a simple problem: how to make a light body that will not sink too fast, that will catch food, that will survive long enough to divide. Diatoms make shell halves that fit together like a box and its lid. Some are shaped like needles, others like discs, others like boats with ribs. When they die, their tiny houses fall. Over long spans of time, the seafloor thickens with white and tan layers called radiolarian ooze and diatom ooze. A handful of this sediment is a museum. Diatom shells from ancient seas have been lifted into the dry world and ground to make a soft, abrasive used to filter and to polish. If you have ever cleaned water through a powder that looks like flour, you may have used the remains of 1 billion diatoms. Among the pebbles of this glass world move bodies that seem oversized for so spare a place. The deep sea likes its giants, though the reasons are a mix of gentle ideas rather than a single law. Low temperatures slow the machinery of cells. Slow machines waste little. Predators are fewer, and hunting is rare and careful. Some lineages have had time to drift toward large forms without penalty. The result is quiet spectacle. Giant isopods walk like armored shoes and hold their meal for months. Giant amphipods, the shape of prawns but thick as a wrist, drift within arcs of their own legs. Squids in the deep can grow longer than stories told by sailors, and the colossal squid carries eyes so large that they can detect the pale signature of whales at long distance. Even fish that remain small are part of this logic. Their bones are thin and light. Their bodies are often gelatinous, a kindness that pressure cannot crush. To live in the deep is to spend slowly and to save carefully. Size is one more way to invest. The water column itself forms bodies that are collectives. Siphonophores are perhaps the most surprising of all. Each one begins as a single fertilized egg, yet the adult is an entire fleet of specialized units joined in a thread that can stretch beyond the length of the largest whale. One unit becomes a float that keeps the body at the chosen level. Others become paddles that row steadily. Others become feeding bells. Others still become stinging soldiers that defend the convoy. Every unit shares nutrients through a common inner canal. To call such a creature an individual is both true and insufficient. It is more like a city that grew from one seed. In the deep, some siphonophores glow with cascades of blue light that travel along the body, as if a small comet were unspooling across the night. Jellyfish, more broadly, are clocks that keep their own hours. Most are water arranged into a bell and some trailing threads, yet within this simplicity are feats that sound like fables. A small species famous for its trick of renewal can return from the adult phase to a juvenile stage when stressed, as if a butterfly could become a caterpillar again and try once more. Other jellies show discipline and endurance that suit the deep. The crown-shaped jelly, often called the alarm jelly, carries a small light at its center and rings it when attacked, not to startle the predator, but to summon a larger one that may drive the first attacker away. Some jellies share their bells with fish that shelter within the curtains and steal a ride to better feeding grounds. The rhythm of these animals is not frantic. Bells pulse and relax in a patient metronome. In tanks at research labs, they sometimes swim in perfect time with the clock upon the wall. Look closely at certain fish and the skull seems to house mirrors. In the dim places where the brightest light is a blue whisper, lenses alone are not the only answer. Some barrel-eye fish use reflective plates made of guanine crystals to direct scarce photons onto their retinas. Mirror eyes allow them to collect more of the light that comes from faint glows and from the soft sky above. In a few species, the eyes point upward under a clear dome that protects the delicate tubes, while also letting stray light reach the retina. The effect departs from expectations. Instead of a face that looks forward, the head is a periscope aimed at ceilings. Bone follows suit. Many deep-sea fish have skeletons that are thin and partly cartilaginous. There is no need for heavy armor in a world without surf or breaking waves. Some forms are so clear that you can read the shape of their organs as if through glass. Rather than a lack, this transparency is a precise solution to the problem of being seen by hungry neighbors. The deep speaks in sound, and if you stay very still, you can hear its choir. There is a natural channel within the ocean, a layer where the speed of sound is lowest. Sound that enters this layer bends back toward it and can travel great distances with little loss. Along this path, blue whales and fin whales send phrases that can circle ocean basins. A single note by a blue whale can be felt by instruments hundreds of kilometers away. Sperm whales make a sonar of sharp clicks that scan like a lighthouse beam. Each click is a packet of sound shaped by special lips inside the head and reflected by air-filled chambers. In the shallows, shrimps crack their small claws to create bubbles that collapse with a tiny thunder. When many shrimps snap together, the sea becomes a fireplace of crackles. In polar seas, the slow shifting of ice gives groans and squeals like the hinges of a cathedral door. The deep is not hushed. It is attentive and layered, a soundscape with both lullabies and drums. Down on the seafloor, the sand keeps notes. Trails left by sea cucumbers write long cursive lines that loop in patient arcs. Starfish stamp small star-shaped imprints and then erase them as arms lift and fall. Rays leave angel wing prints where they have settled and then flown away. There are mysterious spirals that mark where worms have farmed the sediment, and ridges that show where currents have pushed grains into regular patterns. Here and there sit manganese nodules as round as potatoes. They grow incredibly slowly as metals collect around small cores, perhaps a fish tooth or a bit of shell. A few millimeters per million years is their pace, a patience that is difficult to hold in the mind. Pebbles called dropstones rest on plains of fine mud. They fell from the bottoms of icebergs that melted and released their cargo. Even far from ice, you may find the long ribs of a whale, half buried with tiny snails grazing the film upon the bone. To read these traces, you do not need a key, only time and a soft gaze. The bottom writes in a script that cares nothing for hurry. Lift your view and the horizon of the deep is not a flat line, but a skyline of peaks. Underwater mountains, known as seamounts, rise from the plains, and broad plateaus stretch like submerged continents. Many have flat tops because they once were islands trimmed level by waves before the crust moved and the islands sank. Such flat-topped forms are called guyots, a word that sounds like a bell when spoken slowly. Seamounts gather life by interrupting current. Water accelerates as it moves up the slopes and eddies form on the lee side. Plankton concentrates. Small fish hunt the plankton. Larger fish circle the small ones. Corals that prefer cold water and no sunlight build thickets that climb into low forests. Some of these coral gardens are centuries old, with branches bumpy from the slow work of tiny animals. On the summits of the ridges, you can find fields of glass sponges that look like frozen fountains. These structures filter the passing water and stitch together silica like patient lace makers. Currents treat seamounts as hills treat wind. Over the peak, a standing wave may form in the water. On the downstream side, a slowly turning cell of water called a Taylor column can hover, as if the mountain were holding a bowl of fluid in place above its summit. Within this bowl, larvae of many species find a home and grow until they are ready to leave. In this way, a mountain creates a neighborhood in the middle of a plain. Fishers know these places as sources of abundance. Scientists map them as stepping stones for species that would otherwise be scattered. The shapes of these mountains also guide large-scale flows. Chains of seamounts lie like beads upon the strings, where tectonic plates once moved over hot plumes in the mantle. The tracks they write across the ocean floor are quiet biographies of the crust. Sometimes the mountains split and the ridges reveal their centers. There, along the mid-ocean ridge system, the planet renews its surface. Magma rises and cools and becomes new crust. As it spreads, it pulls the ridges apart. Valleys form at the summit, named rift valleys. On their walls are fresh basalts striped with minerals that recorded the direction of the planet's magnetic field at the moment they froze. Over long time, the alternation of magnetic directions forms a barcode written in stone. This has given geologists a way to time the birth of crust and to measure the motion of plates. Even here, life has a hold. Tiny snails and limpets graze upon films of bacteria. Shrimps crowd into cracks where warm water leaks. The hiss of hot fluids and the fall of cold water create a small weather within the larger ocean, with plumes and drifts and quiet snows of mineral dust. If you wonder how the deep endures, consider how slow its clocks run. Animals can take years to mature. Reproduction can be tied to gently falling cues such as the arrival of spring particles from the surface or the small seasonal changes in current. Some fish lay eggs upon the bottom that remain dormant until a particular texture of water arrives to awaken them. The patience of the deep is not a burden. It is an economy. Wastes become resources. Even the bodies of the dead are more than endings. A whale fall is not only a banquet for a few months, it is a career path for worms and a workshop for microbes that drill into bone and extract an energy source not usually available. Over many seasons, the colony changes partners again and again until nothing is left but a faint rise in the mud. The stories of discovery here are unhurried as well. The first vents were photographed late in the decade when the word disco meant a kind of dance. The first global maps of the ocean floor were sketched by listening to echoes and by measuring gravity from ships that crossed in patient grids. Now satellites sense small changes in sea surface height that reveal the mass of mountains below. Robots dive, watch, and return with films that are as serene as they are surprising. We give these machines names that sound friendly. We paint them bright yellow and orange so the sea will not lose them. They look ungainly on deck. In the water, they move with the grace of seals. They teach us that wonder does not diminish with expertise. It grows. Let your thoughts circle back across these scenes, cities of tube worms fed by invisible kitchens, snowdrifts of methane ice that can be set alight in the open air, cathedrals built by single-celled architects using glass, slow giants that do not need to eat for seasons, fleets made of colonies that snake like living comets, bells that ring without sound but in perfect time with the sea, eyes that are mirrors, skulls that are windows, bones that are suggestions rather than walls, choirs of clicks that survey the night, rumblings that drift like fog, crackles that write the weather of shrimp, trails on the bottom that spell out the cursive of hunger and rest. Mountains that keep bowls of water in the lee of their summits, and plateaus that once were islands reading aloud the long travel of plates. Every one of these details is true in spirit and in fact, and yet the deep remains larger than any list. The best way to carry it with you is not as a catalogue, but as a feeling. The deep is patient, generous, and full of small economies. It wastes nothing and it complains of nothing. It holds memories so long that our own memories seem like glints upon a wave. When you breathe out tonight, imagine that your breath joins the long exchange that links air to sea and sea to rock. Somewhere a vent will open. Somewhere a worm will raise a red plume into warm shadow. Somewhere a siphonophore will thread its lights across an unseen avenue. Somewhere miles below, in pressure you cannot feel, a fish with mirror eyes will look up through a dome of living glass and see the faint sky of noon filtered into blue. If sleep comes now, you will be in good company. The deep has been sleeping and waking for a very long time, and it has never missed a tide. Far from the bright corals of the tropics, where parrots of fish nibble stone into sand and sunlight ripples over bright gardens, there are forests that grow with no day at all. Picture wide slopes on the edges of northern seas, the water cold and heavy, the current steady as breath during sleep, Out of that current rise pale branches. They are stony and delicate and entirely alive. These are cold water corals, builders that ask nothing from the sun. Their polyps, which are tiny animals with soft crowns of tentacles, feed by plucking passing particles from the water. Bit by patient bit, they lay down skeletons of limestone. Species such as Lophelia and Madrepora, names that sound like a chant, make thickets and then cliff faces, and with centuries they raise entire reefs taller than city towers. Skeletons keep their own calendars. A thin band records a winter of poor food. A thicker band records a summer flood of plankton. Through these bands, scientists can read a slow diary of climate and current, written in stone by creatures that have never seen daylight. These dark reefs are not empty. Red fish with big eyes hover as if considering a problem. Crabs stand as still as statues until a food scent reaches them, and then they move with crisp purpose. Starfish patrol like careful gardeners, turning over pebbles to search the underside for mussels. Cold water sponges rise like dull candles and filter and whisper. The corals themselves serve as nurseries for the young of many fish that seek shelter among the branches, while their bones thicken and their scales harden. When a branch breaks, it tumbles into a hollow and becomes the seed of a new clump. Here the sea puts down roots without leaves. The forest stands in a night that is all seasons at once. On the broad plains beyond those forests, the snow of the sea falls quietly, the tiny remains of surface life drifting down like the faintest of rain. Sometimes, though, the deep receives a feast. A great whale lives a long life, and then, when time finishes its patient circle, the body numbers one last journey down. At first, the fall looks like a soft dart in the blue, a suggestion of motion in a world where motion is rare. Then the body rests, and the news spreads on scents through the water. Eels arrive, and hagfish knot themselves to gain purchase and tear. Sharks appear out of the dusk and depart the same way, anonymous as thoughts. The first stage is a banquet. In weeks or months, the last scraps of soft tissue are gone. Now comes the long meal. Bacteria create white quilts across the bones and draw energy from the chemicals that drift from the fat that is still tucked within the marrow. These bacteria leave a film that other animals graze. Mussels settle as tiny specks and grow into dense clusters. Worms that carry symbiotic microbes drill into bone and sip the chemistry there the way a tree sends roots into soil. Shrimp and snails creep over the surfaces like deliberate rain. This second stage of the whale fall can last for years, sometimes for decades. An island of life rises where moments earlier there was only the usual procession of sediment. When at last the bones soften and sink into the mud, the island fades back into sea. The deep wastes nothing. It knows how to turn a single body into a city that feeds 100 species. Lift your gaze from the bottom toward mid-water, where brightness is a rumor. Here stretches the world's largest elevator. Each day, when the sun sets, an entire nation of small animals rises. When the sun returns, they descend again. This daily journey is called vertical migration, and it is not a parade of a few meters. It is a climb and a descent of many hundreds of meters, sometimes close to a kilometer. Tiny crustaceans, small fishes, squid and jellies follow the turning of light with astonishing precision. Rising allows them to feed under the cover of darkness upon the rich plankton near the surface. Descending returns them to the relative safety of the dim layer where their bodies are less visible to hunters. The movement is so dense that ships using sonar see a false bottom, a ghostly sea floor that rises at dusk and sinks at dawn. This is the largest movement of biomass on Earth, measured by distance and number, and it happens every single day of every single year without fanfare. It is the slow pulse of the ocean. Now imagine a coastline with a high mountain range on land. The rivers there carry silt down to the sea. Winter storms carve the shelf with sudden energy. The result is a system of canyons cut below the waves. They are as dramatic as their cousins on land, with walls that rise for hundreds of meters and floors that meander in graceful curves. Currents run within them like cold rivers inside a colder sea. Sediment can suddenly surge downward in an underwater avalanche, turning clear water into a dense flow that tumbles blocks and carves new bends. These are called turbidity currents, but the name does not capture the quiet drama. Imagine pebbles drifting like leaves, only much heavier, and imagine dunes forming and moving without a sound of wind. At the head of some canyons, there are plunges as impressive as any land waterfall. The largest waterfall on the planet is not on land at all. It lies in the Denmark Strait between Greenland and Iceland. There, dense water from the north spills into a deep basin of less dense water and falls for more than 3 kilometers. You cannot stand beside it and feel spray on your face, but you can measure it as a cold river that never sees the sky. Elsewhere, slow slumps reshape the canyon walls. The Storegga slide off the coast of Norway happened in the far past, but traces of its huge movement remain as a warning of the power that sleeps in the margins of continents. Submarine canyons focus life as well. Water rushing through brings food, and fish ascend and descend those corridors as if traveling a familiar road. On seemingly empty plains where sand and silt stretch in quiet tones, patches of life gather wherever a little structure breaks the monotony. A single boulder fallen from a melting iceberg long ago can host an entire garden. Pink anemones stand like small sunset flames. Brittle stars set their arms like nets around the stone and wait for passing food. Tubes built from glued sand rise like delicate chimneys, and small worms peer from their entrances, as if considering the weather. When bones arrive, the transformation is even more striking. We have already visited the banquet of a whale. Even the skeleton of a large fish or the skull of a seal can feed an entire village of scavengers and grazers for a long season. On the bottom, architecture is any raised object, any fence for the current to comb, any edge that says stop to grains of sand. The sea uses these small opportunities with inventive grace. At the scale of continents, the ocean floor is a place of birth. Along the mid-ocean ridges, the thin crust of the planet pulls apart, and magma rises to fill the space. The new rock touches cold water and chills into forms, called pillows, that look like smooth loaves of bread. The surfaces crack and new skin forms over fresh melt, and all of it slides away from the ridge like cooled wax slid from a seam. On either side, the plates move in slow opposite directions, a few centimeters in a year, which is still enough to rearrange the entire world given time. From above, the ridge is a line drawn along the middle of the ocean basins, a seam of creation. Earthquakes along this seam are usually small and gentle, as if the crust were sighing. where an offset breaks the seam into sections. Straight fissures cut at right angles and become corridors for currents and for the wandering lives that follow ridges as if following hedgerows across a dark landscape. Not all the new crust stays quiet. Where the crust is thin or a plume rises from deep within the mantle, submarine volcanoes grow. Quite a few lie near island arcs, where one plate sinks under another and water from the subducted slab encourages rock to melt and rise. A submarine eruption is not like a land outburst that sends ash into sunlit skies. It is hot, dark water billowing like ink. Pillow lavas pile upon pillow lavas as if a baker were hurriedly stacking loaves. Volcanic glass forms when droplets of melt meet water so quickly that crystals cannot grow, and this glass, ground by waves and currents, becomes black sand on nearby beaches. The chemistry of these eruptions matters to life. Ash and altered rock release iron and other micronutrients that drift and fertilize wide patches of ocean as if someone had shaken a bag of food over a field. A volcano is not only a furnace, it is also a slow gardener. There are places where ice hides entire seas. Under the thick ice of Antarctica lie lakes that have been sealed for more than many thousands of years. Lake Vostok, named with the Russian word for east, is the largest of them. It is covered by ice nearly 4 kilometers thick, and yet deep below, water remains liquid, warmed by the gentle heat from the earth and pressed by the weight of the ice to stay fluid. Channels thread through the base of the ice sheet and link lake to lake, like arteries in a sleeping giant. Similar systems exist in Greenland, where summer melt feeds rivers that dive into crevasses and roar along the bed beneath the ice. These under-ice rivers carry silt and grind bedrock, and the material they deliver to the sea becomes food for plankton blooms when sunlight returns. In the very cold waters along the Antarctic shelf, brine forms as young sea ice freezes and rejects salt. The brine sinks in shimmering streams called brinicles and can freeze small sea creatures if it touches them. Even here, in what seems the quietest corner of the ocean, the water is busy with hidden roads. If you dissolve a forest, where does its memory go? Rain washes charcoal from wildfires into rivers. Soil releases the dark residues of wood. The sum of these is often called black carbon. Some of it travels down to the sea in a form so fine that it becomes part of the ocean's dissolved library. There it joins organic molecules from plankton and from ancient peatlands. It drifts on currents for decades or centuries. Scientists read this faint ink with instruments that can weigh atoms and separate voices that sound the same to less careful ears. Within that dissolved library are clues to old climates, to the pace of rivers, and to the breathing of continents. The ocean thus holds stories, not only of its own life, but also of forests and fires and the slow work of soil. When we say that the ocean stores carbon, we do not speak only of shells and skeletons that sink. We also mean the black poems of burned wood and the subtle letters of humus, all held in the long, cool pages of seawater. And now back to the smallest citizens, the ones so tiny that 1,000 could fill a pinhead and still have room to dance. They are the engineers and caretakers of the deep. Microbes sit on mineral surfaces and change them by quiet abilities. Some breathe iron, turning its form and its solubility. Others breathe sulfur or manganese. Some fix nitrogen into forms other creatures can use. A special group called Anemox bacteria perform a chemistry whose quiet name hides a powerful service. They take ammonium and nitrite and turn them into nitrogen gas, which then slips back to the air. In doing so, they remove forms of nitrogen that in excess would choke the seas with algae. Archaea, cousins of bacteria with ancient lineage, oxidize ammonia in the dark and release energy to power themselves, recycling and cleansing as they go. Microbes also build. They precipitate minerals that cement loose sand into crust, a skin that keeps dunes from wandering. They lay down thin layers of carbonate that grow into pavements upon which larger corals can later anchor. On the stems of grasses in shallow seas, they grow as sheaths that protect the plant from rot and from grazing mouths. On the hulls of ships, they build communities that engineers must gently remove. In the deep, they gather on the surface of small plastic pieces and create what researchers call a plastisphere, which is a tiny floating city where flows of carbon and nitrogen are rerouted and softened. Even the clear water far from land that looks empty as glass is full of microbial work. Each drop holds time and chemistry. Each drop is a community where vents breathe and seeps dream. Microbes link rocks to animals. Deep sea snails near vents carry iron sulfide scales like tiny shields, and at their feet they farm bacteria that turn chemicals into the nutrition that keeps the snails alive. Shrimps on the mid-Atlantic ridge house microbes in their gill chambers and graze them like livestock. Tube worms, which we met earlier, give most of their body space to microbes and use richly oxygenated blood to carry sulfide and oxygen to their partners. The word partnership fits well here. Neither partner could live alone in that setting. Together they make a small economy in a place that seems to have no coins at all. In all these scenes, from cold, dark coral forests to the under-ice rivers, from silent waterfalls to newborn crust, one thread keeps its gentle pull. The deep ocean is not a void. It is an attentive listener and an exact accountant. It takes what gravity gives it and builds neighborhoods. It turns rare events such as a fallen whale into long lives. It writes in glass and in limestone and in dissolving ink. It revises and revisits. It wastes very little and forgets very slowly. For a traveler who visits only in thought, the greatest surprise is how comforting that carefulness feels. You imagine yourself hovering over a coral thicket that has never seen the sun, and your heart rate slows to match the current. You picture the slow elevator of night, rising and falling with the quiet discipline of the planet, and your breathing matches the pulse. You envision a waterfall in the Denmark Strait, falling for many kilometers in darkness, and the sound is not a roar but a whisper. You think of microbes holding hands with minerals and turning waste back into weather, and it feels like an old house in order. Rest your thoughts on one last image. A basalt pillow, still warm from its birth, breathes out heat into water just above freezing. A thin film of bacteria forms upon its shiny skin, a first coat of life. Over years, a sponge anchors to that skin and grows a delicate cup, and within that cup, a small shrimp chooses a home and spends its entire life in that one room of the cathedral. Above, in mid-water, a siphonophore strings itself like a long necklace and glides with lights that are small as a sigh. Far away and far below, black carbon from an ancient fire finally meets a bacterium that knows how to read it and return its letters to the cycle. Nothing is lost. Everything is slowly rearranged. The abyss is not a mouth that swallows. It is a pair of careful hands that holds. The river of light that the surface gives to the ocean thins to a soft film and then to nothing at all. Here the water keeps other records. It keeps the very small, the threads and crumbs that have slipped from our hands and our factories and our clothes. The travelers are synthetic and they carry the long memory of plastic. At first, they are bottles and bags and handles that float and gather in slow spirals beneath steady winds. Salt and sun and waves and sharp beaks wear them down. Fibers arrive from washing machines by the thousands in a single load of laundry and pass through rivers like fine confetti. Tires exhale black dust that rides rain into estuaries. With time, the pieces become small enough to move with plankton. They join the slow snow and fall. On their journey, films of microbes colonize them and change their behavior. The pieces become heavier for a while and sink, then lighten as the film changes and rise again. This seesaw carries them up and down through layers like travelers who cannot decide which floor to visit. Fish mistake them for prey, birds dip and swallow. The very small, called copepods, taste them and move on, leaving scratches on the surface like writing. In the deep, where currents wander without sun, the pieces finally rest within the mud. Cores lifted from the seafloor reveal thin layers like calendar pages. A distant storm increases river flow and a darker line forms. A flood carries clothing fibers and a pale band appears. This is how the ocean files our habits. The filing is silent. The ocean also edits. On the surface, bacteria begin to chew the carbon chains. On the bottom, worms bury what they cannot use and reduce harm by dilution. The lesson is unhurried but clear. The sea forgets slowly. Past the plains of fine sediment rise shapes that were once swift. Shipwrecks lie like iron reefs along the routes of current and commerce. Some went down in war, some in weather, some through a single mistake in a narrow channel on a foggy morning. Their ribs arch like the frames of cathedrals without roofs. Rust works as a sculptor. Orange stalactites grow that divers call rusticles, made by microbes who live by eating iron. If tanks or pipes still hold oil, it can seep out for years like a wound that never closes. Yet even these wounds become neighborhoods. Anemones colonize the rails. Sponges grow where water speed is right. Small fish weave through ladders and hatches. Big fish circle. The current finds edges at last and throws black mussel seed against metal. They stick and spread in dark carpets. Some wrecks become archives. The cold preserves bottles, shoes, and the letters stamped in brass plates. A century later, the name can still be read by a curious diver. The wrecks are warnings, and they are also cradles for new life, proof that the sea adopts even our mistakes and gives them quiet use. Between the wrecks pass iron travelers that do not sleep. Early explorers rode spheres lowered by cable and watched the deep through small ports with eyes that watered from cold. Then came a vessel named for a rising star. In the year 1960, a bathyscaphe descended to almost 11 kilometers at the deepest point we know in the ocean. The water pressed with a patience that would crush a mountain. At the bottom, the crew saw a plain of grey silt rippled by slow currents, and they saw a small fish or an amphipod glide past. The message was simple. Even here, there is life. The modern fleet is quieter and more tireless. Gliders use a bladder to change their buoyancy by a few spoonfuls of oil at a time. They sink and rise in slow sawtooth paths and convert those gentle moves into forward motion using wings. A glider can cross an ocean on the energy of a single light bulb left burning for a few months. There are thousands of free drifting floats that rise and fall through the upper 2 kilometers and report the temperature and saltiness of the water. They bring news of heat from storms and of cold tongues of water sliding off the edges of continents. There are tethered moorings that ring volcanic vents and listen for tremors. There are robots shaped like birds, crabs, torpedoes, and even flexible snakes that can creep into wrecks or hover over fragile corals without a touch. The deep now has patient scouts who never tire and who surface only to tell us a little more. Humans also dive, drawn by the wish to see with our own eyes. The body answers with limits of its own. As we descend breathing ordinary air, nitrogen enters the blood and the mind grows soft and sweet. This is called narcosis by divers, and it feels like a warm joke that slowly steals skill. Oxygen itself becomes a stimulant and then a poison at high pressure. To reach the depth where daylight fades entirely, divers breathe mixes of helium and oxygen, or even add a careful whisper of nitrogen to steady the mind. They live in small chambers called habitats for days or weeks, so that they need to decompress only once. Saturation diving allows long work at depth, but it is engineering matched to patience. The ascent takes many hours as the body slowly gives back the gases it gathered. Too fast a climb invites bubbles within joints and nerves, a pain that is old in the diving community and always respected. Records draw headlines. A freediver descends along a line with one breath and returns with a surface protocol recited like a short prayer. A pair within a submersible touches the bottom of a trench and returns with mud that looks like wet cement but holds unheard stories. These records are interesting to the world, but the deep teaches a different pride. Good expeditions return quietly with careful notes and many samples still chilled. The lesson is that attention is a better companion than bravery. Even with robots and submersibles, the largest part of the deep is still an outline. How do we draw a map in the dark? The answer begins with echoes. A ship sends a sound down like a firm knock on a door and measures the time between the knock and its return. If the ship carries a fan of transmitters, it can paint a wide stripe beneath its track with hundreds of narrow beams. The result is a multicolored carpet that shows hills and cuts in exquisite detail. But there are wide places where ships have not passed. There the map is painted by gravity. Under a mountain, even one hidden by water, the sea surface bulges by a small amount that sensitive instruments can feel. Satellites circle and measure the height of the sea by bouncing microwave pulses off the surface. The changes are small, a few centimeters, as if a giant had pressed a wide finger into the water. From these subtle clues, a map emerges. It is less sharp than the echo map, but it reveals the big bones of the planet and shows where to send the ships that will later add fine lines and names. Within the rooms, the maps reveal flow rivers that are not rivers in the way we know them on land. A river of cold, salty water forms in the far north when sea ice grows and pushes out salt. The brine sinks and the new water begins a voyage around the world. In the south, something equally grand happens along the edges of Antarctica, where katabatic winds push young ice away from the coast and leave open pools. In those pools, new ice forms, and again, brine sinks. Overflow waters spill from shelves like invisible cataracts, settle upon the bottom, and spread. Elsewhere, the Mediterranean Sea sends a tongue of warm, salty water westward through the narrow gate at Gibraltar. Heavy and quick, it forms a layer that plunges and then rises again, winding like smoke along the slope of the Atlantic basin until it finally thins and blends. Eddies spin off these currents like galaxies. Some are the size of small countries. They live for months. Within them, the water has its own temperature, its own saltiness, its own chemistry and life. From space, they appear as rings of different color, and ships crossing them report sudden changes in wind and swell. Inside the eddy, small creatures have a quiet holiday, feeding and reproducing in a world whose edges keep outsiders at bay. There are waves within the ocean that do not show at the surface. They are called internal waves. They roll along like draped sheets, many tens of meters high, and where they break, they mix water from above and below, loosening the tightness of layers and letting nutrients rise. Because the deep holds these rivers and gyres and hidden waves, it also holds climate. Heat from the surface does not stop at the skin of the sea. In storms, the wind stirs the upper layers and sends warmth downward. The overturning circulation, slow and grand, delivers it further. Over the last many decades, humans have added extra heat to the air, and the ocean has taken most of it gently, like a friend who removes a heavy coat from our shoulders. The upper 2 kilometers now carry more warmth than they did when our grandparents were young, and that heat spreads outward and downward with the patience of water. Carbon dioxide from our fires and engines dissolves into the sea as well. Some of it is carried below by the sinking of cold surface waters. Some is transformed by biology. Plankton breathe in carbon dioxide and build skeletons and shells. When they die, the shells sink and keep a record on the bottom. Other creatures build soft bodies that fall and are eaten, and the carbon is kept for a time in animals and then in sediments. The deep is a bank that stores both heat and carbon, not forever, but for years to centuries. The storage buys time, which is a kind of grace, but the bank is not without cost. Where carbon dioxide dissolves, it makes carbonic acid, and the water becomes a little more sour. Shell builders in cold seas feel this first. We owe them attention. The rules of the deep world follow from energy. Food is rare, so speed is expensive. Many deep inhabitants adopt slow living as a law. Hearts beat fewer times in a minute. Muscles carry more water and less tissue that costs energy to maintain. Growth is measured in ring widths so small that you need a microscope to see them. Lifetimes stretch from years to decades, and in some clams perhaps to centuries. Reproduction is hedged against chance. Some animals release eggs and sperm into the water in clouds so that sheer numbers help a few meet. Others are hermaphrodites, ready to play either part when a neighbor appears after a year without a neighbor. Anglerfish use a strategy so strange that early biologists rejected it as rumor. In the deep, many anglerfish species have tiny males that find females by scent and then attach, becoming permanent partners who share blood and supply sperm on demand. A lure glowing from the head of the female acts as a small lighthouse. It attracts prey and perhaps it draws mates across the dim water. These solutions are careful mathematics written in flesh. Where scarcity rules, size follows its own paths. We met gentle giants among isopods and amphipods and squids. The law is not a single line. In places where predators are few, being large helps survive the long wait between meals. In places where predators are many, being small and clear is another answer. What looks like a contradiction is instead a sign that many equations can solve the problem of staying alive. There are forests of life that share a single root. Siphonophores are one example, corals are another. Colonial animals allow parts to specialize. One part eats, one part stings, one part makes babies, one part builds. The colony is larger than the sum of its parts, and lives longer than any single body should. A wise trick in a place where meetings are rare. Our stories about the deep used to glow with fear and longing. Sailors told of creatures with arms like serpents who wrapped ships. They spoke of dragons that breathed light and of sirens that sang storms into being. The truth is kinder and more complex. The kraken likely grew from real glimpses of giant squids that float upward after dying and spread their arms like a tangle of ropes. The sailors saw what the sea allowed. Luminous dragons exist if you accept the meaning of the words. A siphonophore many meters long drifts with cascades of blue and green light pouring along its body. Comb jellies carry plates that diffract light into rainbows. A school of small fish can turn as one body that flashes and then vanishes, and it looks exactly like magic. There are milky seas that at first sound like rumor. Whole horizons can glow with a faint uniform light on windless nights in warm waters. Satellites have now watched these events from above, and ships have sailed through them. The cause seems to be dense fields of luminous bacteria that release light in a quiet chorus. The famous bloop, a low sound recorded in the late 1990s, turned out to be the noise of ice rather than a beast. The call of a blue whale can be mistaken for the deep background hum of the planet if you do not know how to listen. Mermaids soften into reality as stories of manatees seen through heat haze and wishful hearts. The fictions are not failures. They are bridges from a human mind to a sea that is too large for any single truth. As science draws better maps, the wonder remains. The sea keeps its dragons, but now we can name them gently and describe their diets. The light above us has been patient for a long while. It is time to rise. Imagine our glider pointing its nose toward the surface. The water that presses lightly against its wings has traveled from a polar shelf where young ice was born, and from a tropical rainstorm where a river met salt. On the way up, we pass through jellies that pulse without hurry, through a cloud of plankton that sink again by morning, through the private circle of an eddy that was born last season and will die in the next. We glide past a ruined ship that has become a palace for anemones and a school for juvenile fish. The hull carries the marks of welders who built it when radios had glowing tubes and music was carried by needles and grooves. Rust eats the letters, but we can still guess the name. The sea light brightens from blue to pale green and then to gold. Above us, the first white teeth of a wave grin and pass. The glider surfaces and sends a message into the sky. A satellite hears. On shore, a line of numbers becomes a small, clean graph. A scientist smiles and files it into a curve that will one day describe a decade. Our own ship rises with less grace but with equal gratitude. The ladder is warm from sun, the air smells of salt and wood, and the faint oil of machines that have worked without complaint for a long day. Before we close our notebook, let us hold the images once more. Plastic shavings that drift like frost and then settle into a silent archive that the sea edits slowly, wrecks that rust and yet host gardens. Iron travelers that listen with patience and call home when the sky is clear. Divers who learn the chemistry of breath and the slow arithmetic of ascent, maps drawn from echoes and from the way the sea bulges above hidden mountains, rivers of dense water falling without spray, and eddies that are small worlds with edges, heat and carbon held with care in deep rooms while the surface decides its next weather. Laws of slow living that trade speed for long life and risk for gentle insurance. Dragons that turn out to be colonies and combs and squids, all no less wonderful for being real. The sea is not a stranger. It is the oldest room of the planet where salt keeps time. It is careful with its guests. It wastes little and remembers much. The deep is the quiet library under the bright market of waves. A place where every shelf is water and every book is written in motion and chemistry and light. As you settle now into your own night, imagine a small bell jelly drifting with a rhythm that matches your breath. Imagine a coral forest in darkness lifting its tiny hands to catch a little more food. Imagine a vent chimney pouring black glitter into the cold where worms stand in red crowds like a soft choir. The surface will be here in the morning, ready with its gulls and its sun. The bottom will keep watch in the dark, and nothing important will be lost. Why are the deep places of the ocean still not fully explored, and what could be waiting in that unvisited dark? The answer begins with size and time. The ocean covers more than 2/3 of the planet, and it is not only wide, it is deep in a way that escapes ordinary experience. If you were to stand on the shore and stretch your arm, your hand would touch air that thins gently with height. Water does the opposite. With every 10 meters of descent, the pressure grows by roughly 1 atmosphere, so by the time you enter trenches at nearly 11,000 meters, the weight is like a mountain that presses from all directions at once. Materials that are strong on land become tired and brittle there. Light fails within the first few hundred meters. Radio waves that carry voices in air cannot travel far in salt water. The deep is not hostile in the sense of anger. It is simply a patient world with different rules. These rules make exploration difficult even now. Ships that map the bottom with echoes paint only narrow paths at a time. A modern vessel tracing a careful grid can spend weeks or months on a single square of sea and still leave smaller features untouched. Satellites help by measuring tiny bulges and dips on the surface to guess the mass hidden below. But those guesses need ships to add fine lines later. And ships cost money, crews need rest, weather breaks plans, and the ocean draws long distances between refuel points. Every expedition is a small moving town with constant needs. Communication is another slow gate. Sound travels far in water, but the information you can send with sound is small and the messages are slow. The deep web is not like the air where wireless signals whisper through walls. A robot that wants to send pictures and large data files must rise to the surface or find a cable. A vehicle that is tethered by a cable can stream its vision to the ship. But now the team must guard that long lifeline against rocks and currents and tangles. In the shallows, a diver becomes the brain and the hands at once. In the deep, thinking and doing are separated by thick water and long seconds. You ask a machine to turn, and then you wait for the reply that says it turned. Fragility also slows us on purpose. Deep communities recover slowly from disturbance. A coral branch that took a century to grow can break with the brush of a heavy fin. The sediment that a careless thruster kicks up can take hours to fall, and in those hours, a whole scene is hidden behind a soft blizzard. Ethical explorers move as if in a museum at night, careful with light, careful with breath, careful with speed. That kind of patience is a virtue and also a practical limit. You cannot hurry and still be kind to a world that cannot replace what you harm. There are human boundaries as well. The high seas belong to everyone and to no one at once. Permits, insurance, and international agreements guide what can be collected and where machines can touch bottom. These guardrails are necessary and good, but they add steps and months to the timeline. On the scientific side, the river of samples itself is a challenge. Bringing a bag of mud to a deck is the beginning, not the end. Each scoop holds thousands of species of microbes, dozens of small animals, and a library of chemical information. It can take a team months to extract the first few stories and years to finish the reading. The deep is a patient library. The librarians on deck must be patient too. Energy slows us. A glider can cross an ocean on the power that a light bulb would sip for a season, but that frugality limits how many pictures it can take and how quickly it can change direction. Batteries are better now than in the days when the first floats drifted with paper labels, but 1,000 kilometers is still a long way when you must return to a ship for new power. Engineers dream of charging stations that rise from the seabed when called, of cables that run like quiet roots to vent fields for heat, of surface solar stations with tethers that lower power in the calm of night. Those dreams are slowly entering the real sea, but the sea allows new plans only at the pace of weather windows, budgets, and small successes. All of this explains why we do not yet have a complete map and a complete catalogue. What then might be waiting in that wide remaining dark? The most honest answer is that the sea will surprise us with both the small and the large. Consider life first. There are entire families of microbes that we know only by their genetic signatures. A spoon of deep water holds cells that breathe by using sulfur or iron or methane in ways that were guessed only a few decades ago. On certain rocks, invisible films make minerals grow like frost. In other places, those films dissolve rock and release elements that feed plankton high above. Microbes build tiny cities on plastic bits that drift for years. They modify the chemistry around them and become unintentional markers of our age. New enzymes hide in those films, ways of chewing complex molecules that could one day help clean polluted waters or drive gentle industry on land. The sub-seafloor biosphere extends kilometers into the crust in the form of slow cells that divide perhaps only once in a decade. To stand on deck with a core of warm black basalt in your hands and to know that it holds a living community that has never seen the sun is to feel very small and very glad at once. Within the realm of animals, the list of missing characters is surely long. each year brings news of soft-bodied fishes with faces that look thoughtful, of shrimps that carry light organs like lanterns on a festival night, of worms that wear feathery crowns and drink chemical energy from vents. A few years ago, a siphonophore was filmed that was longer than a city bus by many times, coiled like a glowing wreath. It was not a single creature but a colony where each member had a role. More are out there, some big and ribbon-like, some small and neat as watch parts, each with a novel answer to the quiet math of deep living. It is tempting to imagine monstrous giants that would challenge a ship, but truth prefers elegance over fright. The giant squid and the colossal squid are real and majestic, each with eyes the size of dinner plates to catch flecks of light. They are not hunters of ships. They are sophisticated, long-armed specialists in ambush and escape. Their lives are still mostly unknown. We may learn one day that their migration routes stretch farther than we guessed, and that their spawning grounds lie in places we have not yet sounded. There may be fish of great length that live along the edges of internal waves and feed in the changing flow. There may be octopuses that farm gardens of shell and sponge. There will certainly be tiny predators with jaws that fold like pocket knives and open in a blink. When cameras ride on drifting platforms that are quiet and patient for months without light, they see eyes that glide past like small moons and never return to the same frame again. The deep has many citizens of whom we may gain only a fleeting glimpse. Ecosystems we do not yet grasp likely wait at unusual chemical scenes, brine pools in the Gulf of Mexico that hold ancient salt under newer water, host mussels and tube worms at their edges, and the pools themselves are clear as glass and deadly to an unprotected fish. There are likely brine lakes along other continental margins as well, each with its own chemistry and its own communities. Wood falls and kelp falls that drop from forests and coasts to the bottom become dining halls where strange snails and clams appear that we have yet to name. Even fields of manganese nodules, which look so inert and so dull, hold animals that prefer their hard surfaces to the surrounding mud. The global conversation about mining those nodules is not only about metals. It is also about the life that uses their copper and cobalt and iron not as ore but as shelter. Geology still keeps secrets. Thousands of seamounts have never been mapped or visited. Some will hold cold water corals that are centuries old. Others will host vent fields where superheated water pours through chimneys that grow faster than a tree. In certain fields, the water becomes so hot and so pressurized that it turns into a supercritical fluid, neither liquid nor gas, and its capacity to dissolve metals is extraordinary. The chimneys that form there are like cathedrals plated in copper and zinc and gold. They rise and collapse and rise again as the hidden plumbing shifts. To walk a camera along those colonnades is to feel that you are seeing the planet when it was young. Archaeology in the sea is only beginning to stretch its arms. When the last ice age ended and oceans rose by more than 100 meters over many thousands of years, the coasts where early people camped and worked moved inland. Their old shorelines are now underwater, off Australia and off northern Europe. Teams are finding stone tools on the seabed where rivers once flowed across plains. Caves that were once dry and held paintings or burials now lie behind curtains of salt water and stalactites. A careful diver with a soft brush becomes a quiet historian of families who watch the sea from a very different beach. In the realm of physics, there are questions as well. The largest internal waves can break and stir waters that were meant to stay separate. That mixing changes how nutrients rise to feed plankton and how heat travels to shallower layers. The landscape of eddies, which is a moving mosaic of circles and arcs, may have stable places where animals learn to meet again and again, like crossroads in a dark town. The soundscape of the deep is a layered composition of earthquakes far away, surf carried through the seabed as a long trembling calling wails, crackling ice, and the gentle hiss of bubbles that break from cold seeps and dissolve on the way up. We have only begun to record this music in enough places and for enough seasons to write its score. What keeps all this hidden is not malice and not even mystery for its own sake. It is distance and pressure and time. But there is a gentle revolution underway. Tools are getting smaller and cheaper. A single ship can deploy a family of vehicles that dive at once, some staying near the bottom like careful crabs, others gliding high and slow like patient birds. Environmental DNA sampling lets a team collect a bottle of water and read the invisible traces of who passed through in the last few days. Machine learning helps cameras find the outline of a shrimp or a fish in dim light and suggest what to photograph next. Open data lets a child in a city far from the coast help a scientist classify strange shapes. International projects are knitting maps from thousands of tracks into one living atlas that updates itself with each crossing. None of this rushes the sea. It simply means that we are learning to listen better. What then should we expect, and how should we go? Expect to be surprised by the ordinary. Expect that a new species will look like a clear ribbon at first and only later reveal a clever life. Expect that a lump of mineral will hold a city of microbes more interesting than the mineral itself. Expect that the most important record you collect might be a string of temperatures through a winter storm rather than a charismatic photograph. Expect that a very old community will ask you to move slowly, and that moving slowly will be the best way to see. How should we go? With a museum walk, with a plan to leave no trash, with a promise to share the map you made and the code that ran your robot so that the next team can save time, with respect for local knowledge from fishers and sailors who have watched certain curves in the water for a lifetime, with careful curiosity about how exploration and extraction are different words and different paths, with the calm understanding that a world that takes centuries to build a forest will not be impressed by a quick harvest. In the end, the deep is not empty space waiting for us to fill it with meaning. It is already full. It holds the slow engines of climate, the patient storehouses of carbon and heat, the recipes of minerals, and the longer stories of life written by animals that live at the pace of cold time. It contains a library of forms that remind us the universe enjoys making many answers to the same problem. It holds future medicines and new ideas for materials and quiet reminders about patience. It teaches that worlds can be strong without noise, that communities can be rich even when sparse, and that light is only one way to run a planet. As you let your thoughts lift toward rest, imagine a last scene. A small autonomous glider hums a steady note, checks its sensors, and turns toward the surface, Far below, a pale coral forest on a long slope continues to feed as it has for centuries. In mid-water, a school of lantern fish finishes its nightly climb and begins its slow descent, each fish a tiny star with a timetable as precise as an astronomer. Near a seep, a snail with iron scales scrapes a quiet living from chemistry. On a distant ridge, a young chimney grows by a fingertip in an hour as hot water continues to rise from rock, creating rooms for worms and shrimp and crabs. Above all of this, the first light of morning folds into the topmost meters, where kelp sway and gulls cry. We will not see every chamber of this underwater city in our own lives. That is all right. The sea is good at being old. The important part is to walk with care, to study with kindness, and to tell the stories we do find with accuracy and respect. Thank you for keeping company through this slow voyage. May the memory of the deep rest beside you like a calm tide, and may your sleep be as steady as a lighthouse beam that turns without hurry. Good night.